According to Rolle's theorem, if x is continuous in interval this is a closed bracket, mean A and boundary will be included. If f is continuous in interval a b, मतलब दो points हैं, there are 2 points A and B, that is continuous. In differentiable in interval A, B. I have already told the meaning of this. What is the meaning of open then there exists a point C is 0. Then there must exist a point C where first derivative will be 0. Okay. So, this is a theorem. Firstly, I will explain the meaning of this theorem and then we will try to prove it. Okay. Achha, why I has written that is continuous? Continuous mean I have already explained the meaning of the continuity in the my previous lecture. Continuous. Okay. This is a path, okay. Everything is, please be silent. This is a path and there have 2 points, one initially is A and final is B. If there is no break or this, if this is a continuous between A and B, okay, mean there is every point between A and B I have a neighborhood or there is a no break, this is a continuous, okay. We know the meaning of the continuity, okay. So, including A and B, this curve must be continuous, okay. Differentiate, what is the meaning of derivative? I have already explained that what is the meaning of derivative? The very small change, infinitesimal small change is defined as a derivative, yes. So, if the function is starting from A to ending at the B, that is continuous from A to B, that is a very important thing I have to discuss because it may become in the short question type questions as you have already observed it in the midterm exams, okay. Why I have write the open bracket and A and B? Because according to limit or a differentiation, there must be considered a circle or sphere around ball, yes. But at A, if A is initial point, starting point, and B is a final point, at A there will be a no neighborhood exist at the left side of the A, and the similar there is a no neighborhood at the B. So, A and B must be excluded from differentiations. That is why I have written if in the midterm, in the papers in the exams, I have, if the question is asked about that, why I am use the open bracket, the answer is because the initial point and end point will not have any neighborhood, and that's why that will be not a differentiable, because the derivative mean the variation in a neighborhood. Okay, so that's why. So A and B, when we discuss about the differentiations, we always consider that boundary problem will be boundary values will be not included. So that's why here A and B is included, but here A and B is excluded. Okay, and now the we have to prove that. So there is a not. Sorry, there is some mistake. There are 3 conditions for. And the third condition is that okay, then there must exist a point. If initial and final point is same, then there exists at least one point x naught. There may be a many point. Okay, there must exist at least one point x naught where the derivative on that point derivative of this will be a 0. Okay, and this point is defined as stationary. In some books that is defined as a stationary point, in some books that is defined as a maximum. Why it is called as maxima? This is not maximum, that is a maximum. Maximum doesn't mean they are a maximum, that mean they are a stationary. Okay, there is no change. Okay, now so what is the proof of this? Such that there at least one point x naught such that the derivative x naught must be a 0, and it will be defined as stationary or a maxima. Okay. Okay. So let since FA and FB, the condition according to third condition, FA and FB have a equal value, both are equal at A and B point, both are equal. Let's suppose that constant value is C. C mean constant मैं ले रहा हूँ, 3 ले लो, 5 ले लो, ये किसी वैल्यू के बराबर होगा ना, मैं ठीक है. If FA बराबर है, if FA and FB are 2 points where the function is same, then this line will be, if we apply this condition, According to this condition, we will get the line. What type of this line? This line must be like this line may be a such kind. But at initial and final, if A and B, this is, I have already used this symbol at the definition of function. A mean domain, that at A point and B point, they have the same value. That's why both have same value. Let's suppose that is equal to at that both line, the value is C, okay? Or you may say that this equal to AC, this is BC. And on initial and then final, the curve value is the same. There are three possibilities. Maybe this is a straight line, if I consider the first possibility. For first fx to C for all if all value of x that is mean they remain the same, if the curve is like this constant, okay. So if this is C, value C, okay. This is so fx I have already explained that the domain will be along the x-axis and the range will be always along the y-axis. Okay, so the value of function will be along the y-axis, that is C, and the value of variable changing along the x-axis. Okay, that is x. If this is a constant, I have already proved in the theorem, the derivative will be, yes, derivative will be a, for constant derivative is a 0. First condition, the theorem is straightforward. Nothing to be worried about that. That is exactly the forward, because if that is a constant derivative, 0. So our condition that there must be a point which is 0. So every point on this line will be x naught. Every point will be treated as x naught. Okay, got it? The second point is if it is not constant, then there maybe exists some point x naught that will be greater than 0. एक possibility r less than 0. या तो वो ज़्यादा हो सकती है या दोनों, या fourth possibility हो सकती है. There are some point, there may be a greater than and there will be a less than. For example, in this case, f is greater than c. यानी initial value से ज़्यादा value. Here, if that is x naught, this is xi, let's suppose. Yeah, xm. Initial value from initial and final value that is less than. Though there are two possibilities. Or there are maybe some points, there may be a, okay. So it means if xn naught is greater than 0, mean given is that f a and b at boundary that is a c, but fx naught, if fx naught is greater than c, then it means x naught is not at a b but between them anywhere. Okay. So this implies that, so fx naught, so this implies that x naught will be a b. If we exclude the boundary, that way there will be a anywhere between them. And it will have its maximum value because function because at initial and final that value is k, it means if f is increasing and it coming back to initial value again, it means there may be a some. Yes, because I have explained that x naught is the any point between a and b where fx naught greater than c. Yes, but at boundary f a and b it is a c. It means that will be not at the boundary, that will be between anywhere between the initial and final point. So that's why I use the open bracket. That mean ये लिख लो क्योंकि ये पेपर में शॉर्ट क्वेश्चन के तौर पे पूछा जाता है कि बाउंड्री वैल्यू प्रॉब्लम नहीं हो सकता, बाउंड्री पे नहीं हो सकता, दैट विल बी एग्जिस्ट एनीवेयर बिटवीन देम. दैट्स व्हाई आई हैव यूज्ड द ओपन ब्रैकेट, दैट it is not possible that value will be at boundary but anywhere in between the boundaries. नहीं, बाउंड्री विल बी नॉट इंक्लूडेड. मैं हमने ये इंश्योर किया कि वो पॉइंट मैक्सिमम पॉइंट जो है वो बाउंड्री पे नहीं हो सकता, ठीक है, क्योंकि अगर फंक्शन इंक्रीज हो रहा है, इफ द फंक्शन इज इंक्रीज, इफ देयर इज सम पॉइंट इज अ वैल्यू इज ग्रेटर देन सी, तो बाउंड्री पे तो ये सी वैल्यू है, इसका मतलब है वो कोई पॉइंट बाउंड्री के दरमियान है, ठीक है। और व्हाट इज द रीजन, मैं अभी इसकी बाद में, अगर बाउंड्री से बढ़ ना रहा हो या कम ना हो रहा हो, तो इट्स मीन कि या तो वो लाइन बिल्कुल स्ट्रेट आगे बढ़ रही है जैसे ये बढ़ रही है, वापस नहीं आएगी। If the line is coming back to the initial value, then maximum value will be between them anywhere. जी नहीं, वो तो हमने वैसे डिस्क्राइब किया था ना कि why we have taken it. हमने इस इक्वेशन को, हम तो इस इक्वेशन को देख रहे हैं. Rolle's theorem is applying on this, not applying on this. So if there is increasing and it going back to lower value, चाहे किसी भी तरह, so that points will be a maxima, or sorry, in the case 2 that will be a maximum point, in case 3 they may be a minimum point. So it means the value will be there will be a some point, there will be a maximum value. If there is a maximum value, so it means there okay. Okay, and at maximum value change will please help me, this line is under the area of the video, this point, okay. So at maximum, if the increasing, because the first derivative means the first neighborhood, but that because that is a maximum point, so the change will be a 0 at that point. So at that end, for that points for all that point, the derivative will be a 0, fxi. So the theorem, this point will be also that is not only the x naught. I should mention that x naught mean the at least one point. There may be a many point, there may be a all point, there may be a few point, and the same the case in the case of third, because if there is a less than, it means they will be a for same as 2 case fxi less than c, x naught will be element of AB. Because if less than, oh sorry, not open, this will be open. The same is true for the less than, because if that is less than, that will be also less than the boundary at value. As 1 minute please, as I have already explained, and derivative will be a xi will be a 0 for minimum. Coming back to lower value, fx, b is a final value ना, कि मतलब ये दोबारा अपनी वैल्यू पे वापस आ रहा है, f of b, ठीक है, एंड उससे नॉट c, I must write क्या रखा था हमने, c रखा था, c, ठीक है. सो द सेम केस इज ट्रू फॉर द, सारी एक्सप्लेनेशन वही है फॉर लोअर वैल्यू के लिए, Yes, अब now this is your time. You have a question. आपने कोई क्वेश्चन पूछना चाह रहे थे? अब ठीक हो गया, that's clear. Oh, sorry. Where that has minimum value, as in the case of, you may say that is a J. Okay. Mean maximum पे or minimum पे, and that point R will be defined as stationary. Mean there will be a no change. Okay. So this is the mean value theorem. At maximum, the derivative is the first change in a neighborhood. When things goes upward, and when stay there, they will be a stay for some time, okay, and there will be a no change in a neighborhood point. So at that point, the value will be constant, and so that's why, and that will be always between these 2 points. And one possibility they may be a constant, one possibility they between. Anywhere between them. Actually, in this way, this calculation used in the economics as well as the to reduce the cost. Mean if we find the point where the cost is minimum, our profit is maximum, and we use these formulas for economics as well as the computer science as well as in the physics too. Okay. Your question: why the derivative will be always 0 at maximum or minimum? Yes, if there is edge, there is no continuity. Then it will be not like a circle. For continuous, I have already explained that function behave the property. The left limit will be not equal to right limit. Okay, but so for continuous, it must like a like. So at maximum point or minimum point, it must stop for the closest point. So it is, and derivative always represent the change in neighborhood. Okay. So limit is always defined as a circle. I have already explained. That is like a ball. If 2 dimension, that is line. In 3 dimension, this ball is a sphere. Okay. So along the x. So from left and right, if you are considering the, because it's, here we are considering the line. For line, left and right point must be the same. Here, the left and right point are the not same. If left and right limit approach to 0, if left and right point are not same, then that will become an edge, and there will change in neighborhood will be not a 0. But here, the neighborhood point are the same. If neighborhood point are the same, left and right point is the same, then it means their derivative will be a 0. So that's why the first derivative will be always 0 at maxima or minima point. Got it? आप हंस रहे हो? समझ आ गई है क्या कहा है मैंने? नहीं समझ आई? फिर सुन लो. Whenever things move upward or downward or a maxima or minima, because derivative defined as a variation in neighborhood. Okay, this first derivative will be at the first closest point. Okay, but closest point must be the same according to definition of closed ball. मतलब आपके left और right की limit same होनी चाहिए. So that's why जो है वहाँ derivative जो है that will be always a 0. Okay, got it?